Next speaker is Mr. Ollie Smeenk from SODAQ, and his talk will be about sustainable transportation solutions, exploring the benefits of smart labels and low-power technologies.
Thank you very much. Hi everyone, still awake? So I'm not going to teach you guys anything about printed electronics in the form of creating the printed electronics from a materials point of view or maybe from a production point of view, because most of you already know this much better than I do. Now, where I'm going to talk about is actually how do we use these printed electronics in the real world to make the world a more sustainable place. So I'm Ollie Smeenk. I'm a co-founder of SODAQ. My passion really lies in creating a better world with technology, and I've been doing so for the last 10 years with my company SODAQ. So we are experts in low power, so using as little energy as possible to communicate data from the field, from devices, be it trackers or weather monitoring stations, to the cloud. We use energy harvesting, such as solar or kinetic or thermal energy to power the devices, and we try to make them, with the combination of those two elements, autonomous, so they run by themselves without an external power source, in an ideal case, forever. We were approached by a large player, buyer, Crop Science, to create a smart label, so a flexible label that can be put on every of their 180 million at the time parcels that they ship around the world with seeds. Also interesting for pharmaceuticals. And in here we have printed battery. We have, in this case, flexible etched PCB. And I'll show you a short video as to why we did this. Oh. Is there a way I can show this video? Sorry. Oh well, we will skip the video then, in that case. We'll share it, or you can find it actually on SODAQ's YouTube page, but basically showing different use cases of transporting goods around the world. These trackers can be used for monitoring temperature along the way, monitoring location, monitoring shock. So if the asset is knocked or handled poorly, knowing where in the supply chain that happens. And the real key component is that they communicate via cellular, so via the mobile network, which is was the world's first at the time we developed it for a printed solution. Now, one of the other reasons we did it in this way is that traditional asset trackers, which we've also been making, lead to a lot of waste in very hard to recycle batteries. And so with these kind of printed battery solutions, which is in this case zinc manganese oxide from a company called Imprint Energy, is fully recyclable, so can actually be fully taken back, and the components can be brought into a new production process, or can be separated with regular waste. Now, I'm going to talk a little bit about life cycle assessments, about environmental impact. There is, of course, a lot of factors to environmental impact. The one that I'll be pointing out a lot is actually the global warming aspect, so CO2 emission. The reason why I've selected CO2 emissions is because it's quite a known common standard that's measured across different industries, so we can make comparisons. But it's actually a very simplistic way to look at impact. I suggest looking at a company, Fairphone, and their impact reporting to really see state of the art when it comes to all the practices related to impact. In this case, we're also looking at environmental impact and the impact on people. So a traditional asset tracker like this one that we produced, in this case with a solar panel, I'll show you a use case in just a moment. It does about 17 kilos of CO2 equivalent emissions to make this device. So